Welcome back to the training series of TAE certification. Today we will start with section 4.2, Risk Assessment and Mitigation Strategies. In this session, our agenda includes a comprehensive discussion on risk assessment and the strategies to mitigate those risks. Technical issues can lead to product or project risk. Typical technical issues include: number one, too much abstraction can lead to difficulty in understanding what really happens, for example, with keywords. So in the previous chapter, we discussed what is abstraction and what are the benefits. For example, in keyword scripting, the keywords offer abstraction to simplify complex systems by hiding unnecessary details. So that's really beneficial, but if you abstract too much, it can make it difficult to understand how the system works. So when the code becomes overly abstract, it may be challenging for the developers to make changes or fix bugs because they can't easily grasp how different parts of the system interact. And debugging becomes harder because it's tough to trace the flow of data or control through highly abstracted code. Number two, data-driven. Data tables can become too large or complex or cumbersome. So we covered data-driven scripting earlier as well, where data is used to configure or drive the behavior of the system. So however, if these data tables become too large or complex, it can result in several risks. For example, it can result into performance issues. Large data tables can slow down the system, leading to poor user experience or even system failures. They can be maintenance challenges as well, because complex data tables are harder to update and maintain. Then there can be data integrity risks, because with the complex data tables, it's easier to introduce errors, leading to data inconsistencies or incorrect system behavior. Number three, dependency of the TAS to use certain operating system libraries or other components that may not be available in all the target environments of the SUT. This point addresses a common problem in software development where a TAS relies on specific operating system libraries or other components. If these dependencies are not available in all the target environments of the SUT, it can result in significant risks, like there can be compatibility issues. The TAS may not work in certain environments, limiting the scope of testing and potentially missing critical issues. Then there can be a maintenance overhead as well. If dependencies change or needs update, it can require extra effort to keep the TAS functional across different environments. So picture a testing tool that only works with Windows, but your product needs testing on both Windows and Mac. You are stuck with incomplete test coverage in this case. Typical deployment project risks include: number one, staffing issues. Getting the right people to maintain the code base may be difficult. This risk refers to the challenge of finding and hiring skilled personnel who can effectively maintain the project's code base. This can slow down development and potentially lead to quality issues. Number two, new SUT deliverables may cause the TAS to operate incorrectly. When the SUT undergoes changes, it can affect how the TAS operates. The TAS may not function correctly due to modifications in the SUT, leading to inaccurate results or failed tests. Number three, delays in introducing automation. Introducing automation into a project can take time, especially if it involves creating test scripts, setting up test environment, and training the team. Delays in this process can prolong the project's timeline and may result in more manual work than initially planned. Number four, delays in updating TAS based on the changes done to the SUT. As the SUT evolves or undergoes changes, the TAS must also be updated to remain compatible and effective. Delays in updating the TAS to align the SUT changes can occur due to many reasons. For example, resource constraints or complexity of changes. Number five, the TAS cannot capture the non-standard objects it is intended to track. Okay, let's first understand what are non-standard objects. So non-standard objects refer to elements or components within a software application that do not conform to conventional or widely recognized standards or patterns. These objects might include custom-built user interface elements or specialized controls. For example, a CAPTCHA image that requires human verification to proceed, that is a non-standard object. Then a calendar widget that has dynamic dates and events is also a good example of a non-standard object. Potential failure points of the TAS project include: number one, migration to a different environment. Moving your TAS to a different environment involves configuring and adapting the TAS to work seamlessly in the new environment's infrastructure and settings. If the migration is not handled correctly, it can result in issues like test failures, data inconsistencies, or disruptions in testing workflows, ultimately affecting the reliability and effectiveness of the TAS in the new environment. Number two, deployment to the target environment. Okay, so deploying the TAS to the target environment where actual testing will take place is a crucial step. It involves setting up with automation infrastructure and ensuring that it operates correctly within the specific environment where the software test resides. Number three, new delivery from development. This point refers to the introduction of new software or code changes from the development team to the testing environment. When new code is delivered, it needs to be integrated with the existing TAS to ensure that testing remains up to date and reflects the latest developments. If the integration of new code is not seamless, or if it introduces unexpected bugs or conflicts with the TAS, it can lead to incorrect test results or testing delays. So ensuring that the TAS remains synchronized with new deliveries is critical to maintain the integrity of the testing process. So in summary, these potential failure points in the TAS project highlight critical moments where issues can arise and impact the effectiveness of automated testing. Proper planning, coordination, and testing of these steps are essential to mitigate risks and ensure the success of the TAS project. There are a number of risk mitigation strategies that can be employed to deal with these risk areas. These are discussed below. The TAS has a software lifecycle of its own, whether it is in-house developed or an acquired solution. One thing to remember is that the TAS, like any other software, needs to be under version control and its features documented. Otherwise, it becomes very difficult to deploy different parts of it and make them work together or work in certain environments. So TAS goes through its own journey, whether we build it ourselves or buy it from somewhere. Now, here is the key. Just like any software, we have to keep it organized. That means putting it under version control so we can track changes and keep things in order. Plus, we need to document all of its features. This is because without these, things can get messy. It can become really tough to use different parts of the TAS together or get it to work smoothly in different situations. So version control and good documentation are like the secret sauce to managing and reducing risks with TAS. Next we have also there has to be a documented, clear, and easy to follow deployment procedure. This procedure is version dependent, therefore it has to be included under version control as well. So this plan can change with different versions, so we have to keep track of it. There are two distinct cases when deploying a TAS. Number one, initial deployment. This is when we are setting up the TAS for the first time. And the second one is maintenance deployment. And in this case, TAS already exists and it needs to be maintained. Let's start with the initial deployment. Before starting with the first deployment of a TAS, it is important to be sure it can run in its own environment, it is isolated from random changes, and test cases can be updated and managed. Both the TAS and its infrastructure must be maintained. So you can see over here there are few bits which are highlighted. So now we will go through an example and then relate to these highlighted bits. Okay, so when it comes to initial deployment, think of it like setting up a brand new computer. So before you start using it, you want to make sure that it works properly at your home or office. In this case, home or office is referring to its own environment. Then you wouldn't want it to suddenly act up because of the unexpected changes like a sudden power outage or a virus. In this case, the power outage or virus are the isolated from random changes. Now imagine you have some important documents and files on that computer and you want to make sure you can easily update or organize them whenever needed. So in this case, the documents and files on the computer can refer to the test automation solution, and in order to be able to update or organize them whenever needed, this will be test cases can be updated and managed. It's like having a well-organized filing system. So lastly, just how you would maintain your computer by keeping it clean and ensuring all the parts work smoothly, you need to do the same for the TAS and the computer surroundings. Now, the computer surroundings can refer to the infrastructure. So before you deploy that computer for use, you make sure that it's in good shape, safe from surprises, and easy to manage. In the case of first-time deployment, the following basic steps are needed. Define the infrastructure in which the TAS will run. Create the infrastructure for the TAS. Create a procedure for maintaining the TAS and its infrastructure. And create a procedure for maintaining the test suite that the TAS will execute. So just like setting up a computer for the first time, these steps help ensure that when you start using the TAS, everything is in the right place, it works smoothly, and is easy to take care of. The risks related to first-time deployment include total execution time of the test suite may be longer than the planned execution time for the test cycle. In this case, it is important to make sure that the test suite gets enough time to be executed entirely before the next scheduled test cycle begins. All right, so let's relate this risk to our computer setup example. So think of this like expecting your computer to finish a big software update in 30 minutes, but it takes an hour. The risk here is that the computer, or TAS in our case, might not finish its tasks on time. So to avoid this, you need to ensure that the TAS has enough time to complete all of its tests before the next scheduled round begins, just like giving your computer extra time for that lengthy update. Then we have installation and configuration issues with test environment exist. For example, database setup and initial load, services start or stop. In general, the TAS needs an effective way to set up needed preconditions for the automated test cases within the test environment. Okay, so imagine setting up your computer, but you encounter problems like getting the printer to work or connecting to the Wi-Fi. So these are installation and configuration issues. Similarly, when deploying the TAS, you might face issues with things like database setup or starting and stopping services in the testing environment. So to manage this risk, the TAS needs a smart way to handle these setup tasks smoothly, just like making sure your computer's initial setup goes without a hitch. So we are done with the initial deployment, and we will continue with the maintenance deployments in the next session. Till then, happy testing.